Thank you very much, Ian. Yeah, good afternoon, everyone. I hope everyone's doing all right. If anyone is stuck in the heat wave at the moment, it's yeah, I think we're all suffering with that at the moment. Yeah, let me just get my camera and that on for you guys. Come on, there we go. Can you guys see me all right? Yep, brilliant. Okay, cheers, Ian. Yeah, so good afternoon, everyone. So my name's Luke White. I'm actually part of the MSc AI teaching team, and as Ian has alluded to, I teach one of the modules right at the end of the course called Impact of AI. And the idea of this module in particular is around understanding how we actually bring AI, machine learning into, practical use cases and the potential impacts of that from a ethical standpoint, economic standpoint, social standpoint. So it's very much a conceptual module, and it's more about learning how to deal with actually practically using AI in a realistic way. Because obviously there's certain expectations that some people may have about AI that may or may not be true. So if you guys may have experienced this in companies before or previous work, promises and things, hype around things like AI can be quite strong sometimes. So this is where a module like that is quite useful for understanding, exactly what is realistic, from a delivery point of view. If you're tasked with building such a system, it can become quite interesting what people expect it to do, and it can't actually quite do that. So, but it can do a lot of very good things, which is what obviously we're here for. So what I'll do, I'll start the presentation. I'll do a bit more formal introduction about my research and things like that. So let me share my screen. Ta-da. Come on. There you go. Can you guys see that okay? I might have to move you in somewhere else. You guys see that all right? Let me just double check the chat. Yep, perfect. Okay, right, we'll carry on. So, minimize that. Okay. So obviously the talk for today is around AI algorithms. This is the first talk of two that I'll be delivering. The second one is more around, as Ian has also mentioned, linear regression and also a bit more of the mathematics behind it, which again, as Ian has also mentioned, it's not necessary to be able to, write down the algorithm for this perfectly. And be able to, recite it. It's more about just understanding how these things work, and it can really expand your understanding and how to use certain algorithms in certain ways and what are the benefits and drawbacks of certain ones. So as mentioned, I'm Luke White. I'm part of the teaching team. I'm also a PhD student at the university. I'm currently nearly 2.5 years in to my PhD, so not long left. And my research mostly focuses around the use of machine learning and what's referred to as big data in social care. So obviously you've got a very big crossover there between two very different domains, and that's something I'll talk about in this talk as well, and kind of expand on how the domain that many of you guys will have come from will be somewhat different to this, and that is actually a very important thing to have, a very important trait, whereby you can bring that domain knowledge into this area. And that's one of the great things about AI in general, is that it's very much a tool, and the domain is also a very important component of it. So, if you've come from, say, finance, or you've come from healthcare, or you've come from, science discipline, or even just computer science itself, having that domain knowledge is really useful for when implementing AI algorithms and AI systems in general. So I've currently got a paper that's almost finished. Well, it's been submitted, so I'm fingers crossed that will get accepted. But yeah, so that's currently where I stand at the moment. I also have some previous experience in software development and software testing. That's sort of my main background. And my undergraduate project was around using neural networks for designing circuits for microchips, so programmable chips, taking a specification that a user would provide and then turning that into a real tangible design that could be put on a microchip effectively. So what is this talk actually going to be about today? Well, we're going to look at how AI is currently used practically, what those applications sort of are, the domains, and how we think about and how we go about developing our own AI products and services, because this is quite a particularly involved task, and it's very conceptual and high level. So don't worry, I won't be scaring anyone with too much programming in this talk. There might be some mentions of it, but I hopefully won't scare anyone. So yeah, so going on from there, the very first question is, how do we use AI now? And the first thing we need to consider is what kind of functional domains that exist within AI. So what can AI actually be used for? So at the moment, with our current abilities in machine learning, artificial intelligence, we have various set of domains that can be achieved. So some of the ones you will be very familiar with, things like computer vision, speech recognition, text to speech as well. These kinds of things that you will have seen every day. Even things, your phone is absolutely packed with this kind of stuff already. And it's quite interesting how it's worked its way through into effectively everybody's own personal devices, almost without fanfare in a way. It's just kind of appeared. And also things like social media as well. Various prominent social media platforms use algorithms and machine learning to determine what content is shown to you. These are obviously known as recommendation engines. These are also, the kind of things that control, for example, you on your phone, there is almost like a news section. There's like a feed that is provided to you on your phone. And sometimes that can be scarily accurate. I've certainly found that myself. And that is obviously dictated by the data that is collected about what things you search, for example, what apps you use, what various shops you go to, your location, things like that. So it can sort of work out things about you and then recommend certain things. Again, we have all these other domains such as robotics as well. Robotics is a bit of an interesting one because it's not necessarily the building the robot itself where the AI is strictly speaking used. It's more about the control systems and also, providing robots with sensory input that we can then interpret using AI. And again, a lot of these domains have vast subdomains as well, such as NLP or natural language processing, computer vision, and speech processing specifically. Predictive analytics is another one that's very interesting. So like forecasting, for example, this is something that is a very broad field and is something that I personally work in. So if you have any questions about that, then more than happy to answer them for you. The next thing to talk about is application domains. So how AI is used in various areas. So really, strictly speaking, AI can be used in effectively any domain. You can use it really in any way you can think of, so long as there's some kind of human process or skill or something like that that you're looking to potentially emulate, or there's some kind of reasoning or logic that you're looking to improve, etc. So, for example, on the actual MSc course, part of the Impact of AI module, students will look at doing something called a horizon scan report. And the idea with this is that they choose a domain, and it's usually something that's very close to their heart. It's something that they're very interested in or that they've come from previously. And the idea is we ask them to design an AI system in that area, and how would that work? What would be the benefits of it in that area? And this is where I've referred to before about how domain is actually really important. So half the battle with AI systems is understanding your domain. So, for example, what may work in healthcare may not necessarily then work in finance. So you have to, use your experience, for example, to understand exactly what processes and approaches might be relevant or not relevant, depending on what domain it is you're looking to deploy AI into, for example. And again, really, this is this has obviously got a lot of examples here, but to be honest with you, it can be basically anything that we can apply our imagination to for it. So what might be useful at this point is, how do AI systems actually work? So how does an example system work currently? And I'm going to use a very sort of popular example. A lot of you will probably have seen these systems before, which is AI assistants. So this can be things like Alexa, Siri, Google, etc. Cortana, which, as far as I'm aware, nobody uses. So the idea here is that an AI assistant uses either your voice, so speech, or text. You can, provide a text prompt in the case of, say, Google, Siri, etc., to do something useful. So, for example, it might be a case of, like in this image here, is asking for what the weather is today. Obviously, I think everybody knows what the weather is today 'cause it's so warm. But yeah, you can do basically anything with these. So, adding things to calendars, timers. You can actually install third-party add-ons and do all sorts of crazy things that you would like to. But generally speaking, the key thing we want to look at here is, what is the user's perspective on using an AI assistant? So to start with, obviously a person will talk or give text to the AI assistant. And effectively what's going to happen here is, in this case, you've got the step one here, which is obviously the data coming in, which is your voice or text. Step two is there's going to be some kind of processing of that information, of that data coming in. So that's where we use something like natural language processing, or NLP. And this is then going to go to some kind of back end somewhere, some kind of server that's going to process that information. And what we refer to here as APIs. So all API refers to is a application programming interface. This just means it's a way to communicate with an application or a server, for example. So we can take that NLP that's going to say, this person has said this. I'm going to pass that over to the server that is then going to come up with some kind of response, and then pass that back to the assistant, which then responds. So in that case, we've seen, say, things like the devices like Alexa, you speak to it, it does a bit of loading for a couple of seconds, then it comes back with a response. So it goes off, understands what you say, provides that to some kind of server or some service, and then returns a response, which then it gives back to you. So going on from there, infrastructure. Okay, so that's the first part. So the first part we just looked at was, as it were, the user side of things. So this is now what that service or server side infrastructure looks like. So this is an example here from Google's cloud platform. And they have something called Dialogflow, which is just, again, it's just another name for this kind of assistant speech recognition process. And really, I'm not too worried about, going through the actual depths of exactly how this works, because you'll be surprised to know that companies like Google, Amazon don't actually, strictly speaking, give out the full details of how their platforms work, obviously for commercial reasons. So here we've got a very simple example of how you can have a AI-based assistant. So really, we've got this dialogue flow on the side here. So, you talk to it and it provides some kind of generic response. And then you give the actual instruction you want. This goes to something called the App Engine inside Google Cloud. I'll explain what these are. So all this App Engine is effectively like a computer. It's like a server. It's something that's going to be running that dialogue flow application for you. So when that instruction comes in, it's then processed and it's going to interact with things like a database, in this case, an SQL or a cloud SQL database. It's going to talk to some sort of storage if that user already exists, or it's looking for, storing an image, for example, that they've uploaded. And this, in this case, is GCS, which is Google's cloud storage, hence the name. And then you've got this Dialogflow API, which will take that prompt and turn it into some kind of actionable thing. So that's the NLP part. That's the bit that's actually going to understand what was said. And again, it's got this vision API as well. This does as the name suggests, the image recognition on the image that's been uploaded. And then it also interacts with things like a calendar and things like that to understand, things like, because the calendar can have other functions like dealing with locations and things like that. So again, this is a very simple example of what goes on within the infrastructure of such a system. And again, this can be a variety of different things. And one point I'd like to highlight throughout this talk is that there is no single correct way of doing this. So this is a very young field, AI and building AI systems. So really, strictly speaking, there is no right or wrong way of doing this. But there will be trade-offs for, platform performance, how, responsive your application is, for example, the accuracy of your models, for example. And again, there's a huge host of tools available that will let you do basically anything you like. So going on from here, the very last component of an AI system that exists currently is we have this idea of a machine learning lifecycle or a model lifecycle. And so at the moment, we've seen our user final application we want our AI to be in. We've got the infrastructure that helps facilitate that. And now we need the actual models that do the actual AI part. And this is usually done through some kind of formal lifecycle. Now, in this case, what I've got here is the Microsoft data science lifecycle, or data team process lifecycle, as they call it. So this is effectively a blueprint, as it were, for how to create and manage your machine learning models and your data. So again, this isn't the only way to do this, but this is certainly a good starting point if you're looking to, get that formal understanding of how these things are done in practice, and especially seeing as it's coming from a company like Microsoft, I'm sure that this works for them. So notice the very beginning of this life cycle, the first thing you've got to know is the business understanding. And if you've ever worked in software before, or frankly, any company that produces a product, then having that business understanding is, of course, always one of the most important things. And again, this is where I mentioned about the domain knowledge is really important. Going on from there, you have things like data acquisition and understanding. This is about, understanding what data you have available, how do we process it, where do we store it, these kind of questions that are really important, and the data wrangling, exploration, and cleaning, which is something you guys have looked at a little bit today. And yeah, so really from there, you now have your data presumably kept in some kind of storage or capacity or processed in a certain way. From there, you can then do your modeling, for example. So this life cycle kind of can go in any direction, but strictly speaking, you would go to the modeling next. And from here, you would then choose things like, feature engineering. All that means is, which data is important. Model training, this is something that you guys have just been looking at. And, it's about, taking that data and training an AI algorithm against it, and then you produce a model. So when I refer to a model here, what I mean is an algorithm that's been trained on some data, and you then have your final trained model in this case, which is what you use to then make predictions, forecasts, etc. One of the most important steps in all of this is the model evaluation. So this is something that I really harp on about, especially in the module. But understanding whether or not your model works well is a massively important part of any AI or machine learning process. Choosing the right metrics, doing the right testing, and as Ian mentioned not too long ago, saying about how you can take, for example, keep some data back and then test your model against it to see how well it's actually doing. So this is what we refer to as validation. And really, this is one of the most important things. And especially seeing that certain evaluation metrics may work better than others for certain things. And you have to always keep an eye out for things like bias. Again, this rule relates back to things like ethics, which if your model is biased or your data is biased, your predictions are also going to be biased, and then that becomes obviously a huge problem. And there's been many examples in the media about this happening, such as Amazon's hiring AI, which would screen CVs, and hire people or not hire people on various characteristics such as race, which obviously became a massive problem. And they didn't think to, properly vet this, or clearly they didn't vet this in the correct way. For the final stage of this is deployment. So this is actually turning your model into something that is usable with the rest of the application and the infrastructure that you've already developed. So in this case, you will package your model up into some kind of deployable, for example, like a file. And really what you're then looking to do is you integrate that with your infrastructure and your application, and then you need to be able to monitor it. So how well is this model actually working now that it's, in the wild, so to speak? Now that you're getting data that it hasn't been trained on, now that you're getting it's being used in use cases that maybe weren't, outside of the realms of testing, how well is it actually doing? And monitoring the performance and then maintaining and updating models is also another really critical piece. So just to conclude this section, because there's quite a lot going on here, is you basically have three main components of any kind of AI system that's in industry. You have the end user application service, what have you. So this can be a phone app, this can be a web page, or it can be like integrated with other applications that already exist. Then you've got the infrastructure that deals with, serving that application's information. So things like databases, storage, handling files, and also then, returning the information that the AI models actually provide. And then finally, the last piece of the puzzle is the models themselves, and this is governed by some kind of machine learning lifecycle. So let me just double check the chat, see if there's any questions, because I can't quite see it on my screen. Oh yeah, Google Cloud Storage, yeah. Yeah, exactly. So yeah, I'll let you know some APIs as well. But like you say, yeah, there is no right or wrong way of doing this. So there is only more efficient ways. That is correct, yeah. So and really you'll notice that various companies and things like that, they're kind of almost like leapfrogging each other on about, producing the best systems. I will actually talk a little bit about keeping up with AI in general and how, developments are, because it's quite an interesting field, as hence why you guys are here. And it can be quite difficult sometimes to keep up with how many new developments there are all the time. And I'll, just provide my personal advice on how I go about that anyway. Okay, so this is where the main thing that hopefully you guys will be interested in. How do you go about making an AI system? So the way that I phrase this is as a series of questions for each stage of building an AI system. So the first thing to consider is that this is what's known as ML ops, or machine learning operations. So if you've come from a development background or a software background, you may have heard of DevOps before, or DevSecOps, which is development security operations. And these are things relating to, managing how we write code and how we deploy that code and building applications, etc. So all this refers to is the same kind of thing of, how do we actually build machine learning models and how do we deploy them in its own, acronym, ML ops in this case. And as you can see here, you've got the various stages of it. You have your data, you have to collect it, process it, store it. You have your ML where you do your actual training and then you create the model. Dev is the actual application that people see and, all the infrastructure around it as well. And then the ops is, dealing with, monitoring and releasing it and etc. and actually getting it out into the real world. So one thing I want to highlight here is as part of ML ops, it's not just, say, one type of person that works in this space. It's actually a wide variety of people. So we have this idea of, data scientists, which are, one of the main components of, ML ops or building AI systems. Data scientists are the ones that do the model training and dealing with, exploratory data analysis and working out what models will be best, etc. But we also have a variety of other roles that exist. So we have things like ML engineers. These are people that deal with the packaging and deployment of machine learning models. We have data engineers. These are people that obviously deal with the inflow of data coming into your system and storing it, etc. We have DevOps as well. which again is sort of the more programming side of, dealing with, deploying applications, testing it, doing monitoring, all that kind of things like that. You also then have privacy security experts. So this is where things like pen testing comes in. If you're releasing any piece of software into the wild, you kind of have to do testing to make sure that it's safe and secure and people's data isn't at risk. And again, this goes into things like then GDPR. So this is governance stuff, and making sure that whatever you're building actually complies legally. And concerns and things can be raised before they appear in the wild, as it were. So that's sort of most of the backbone around MLOps and what that kind of means from a practical standpoint. And one thing I wanted to highlight as well is what you'll notice when I'm going through a lot of this and talking about this is that the actual machine learning code that you guys will inevitably write and produce models with is actually a small part of the whole picture of building an AI system. This image comes up quite a lot when you look into MLOps and things like that. And strictly speaking, you have all these other tasks that are kind of associated with producing an AI system, dealing with data collection, verification, all the feature engineering, understanding how well the model works, all the automation, DevOps, testing, all of this other stuff. So what I would say is that understanding machine learning operations and AI in general isn't just purely writing code. It's actually this huge swathe of different tasks and jobs that need to be done in order to actually make these systems real. So I hope that makes sense, guys. I'll just double check for any questions. Yeah, so yeah, of course, it is a very complex field. There's a lot going on. And obviously, like you say, if predictions are wrong, this again is, how do you deal with that? So this is something I'll talk about shortly. Really, it's about if a prediction is wrong, for example, obviously what you should be doing is monitoring that model. So you will know straight away that a prediction has come up potentially wrong, or it's thrown, or if someone has reported that as an issue, then you must go back and review exactly why that may be. And this is where choosing things like your evaluation metrics for your models is really important, because your models, your metrics dictate what kind of things you're measuring in your model. So if you haven't, say, got a vast, a wide enough suite of metrics and things like that, that's where it can go wrong. And also things like it may be just the case that the data provided, is never going to be complete. That is quite often the case. The data, the idea, with machine learning is you're teaching it to understand something based on a sample of all the infinite real world data that exists. So again, it's a model, so it's going to approximate what that thing is, and it may not be necessarily the case that it's always going to get it right. But obviously our job in this field is to try and make sure that these things are safe and as accurate as possible, and try and to mitigate these kinds of issues. So I'll talk about a few of those in a bit. So the very first thing that I'd like to talk about is in building an AI system, the very first thing you want to do is to understand your users. So this kind of also applies to software engineering or software development if you've been in that field before. Really, the main thing is who are we building a AI product for? So it may be tempting to make an AI product in practice that is cool, because obviously AI is cool. That's why you guys are here. And really, there's a variety of ways you can do this. We have things like user stories, personas. Obviously, your own domain experience is very helpful here in understanding, exactly what kinds of things are required. So, for example, for my PhD, I don't have a huge amount of experience with social care, but I'm working with a company that does, and their experts have been completely invaluable in me understanding how I can build AI systems in that context. So again, working with other people, having that domain experience is really important. You can have surveys as well as another possible avenue, and this is generally comes under the umbrella of market research. So as part of user stories, as the diagram shows here, you kind of have a few different aspects of it. You have the persona. So this is a person that you create who would be, say, a candidate user of your system. You have the need. What is their actual intended use of the system that you're producing? And then obviously the purpose is, why would they want to use that? So, you know, for example, if we take an example like video games, for example. Now with video games, you know, there's a lot of things going on in there. It's mostly it's a user-driven thing, and typically speaking, a user will play video games or a video game because they want to enjoy it. So, how could we use AI in this case? Well, what we could do is, you know, the behavior of, let's say, enemies or enemy players in a video game can be adjusted in such a way to maximize people's enjoyment of a game. So, and this is something that has been done, and I've worked with students before who have done similar things to this, where they've used, you know, an AI or machine learning based system where they dynamically adjust difficulty and things like that, to the goal being to maximize the person's enjoyment and engagement with the game. So again, you know, writing this out, it may seem funny sometimes. I've done this before because you have to come up with like a name and like details about this fake person, but it can be quite an interesting experience because it does really show up things that you may not have considered about the thing that you're going to make. So going on from there, now we understand what our users want. We need to understand the problem domain. Okay, so again, what do our users want? What is it actually they're looking to solve? And what type of problem is this? Is it a human skill? Is it something like vision or speech or common sense reasoning? Is it a formal task like playing a game, or mathematics like validating various things or generating geometry and things like that? Or is it something that we would consider an expert task? So, you know, engineering, you guys may have seen before that in computer-aided design, we now have tools available that can use effectively ML and AI to generate designs for you. So you give the specifications you want, and it generates the parts for you, and they look really kind of interesting. They almost look organic. And again, this is where this is sort of making progress. Medical diagnostics, you know, is this a task where, you know, you want to take a CT scan of somebody's lungs, for example, and try and diagnose cancer? That's something that, again, AI has been very useful at, because it almost works in tandem with the expert or the person who's specialized in that area. And things like financial analysis as well. Forecasting is a huge part of financial analysis, and using machine learning systems to do or enhance that is obviously a massive deal. So again, after considering what your users want, you have to decide what it is, and obviously what AI problem domain it is that we've talked about before. And from this, what kind of techniques can you use? So for example, if you're dealing with speech, you would use something like NLP, for example. If you're doing computer vision, then you might do something like, you know, neural networks or convolutional neural networks, because those are specifically designed for dealing with images. You know, reading, you're doing, you know, text analysis, etc. So the idea is it can help eliminate what kind of techniques and methods you can use for your particular problem that you're trying to address. Again, now that you have a range of techniques that may be suitable or may not be suitable, you need to find the solution that will work best for your particular AI system. So again, you have to consider what technique would be best, and how would somebody interact with this? You know, what is the way that a user would use this in the real world? Is it something like a mobile phone app? For example, things like Snapchat, Instagram, they have filters. That is a prime example of a machine learning or AI based system. You know, they've gone and thought, people want to touch up their photos. You know, again, what technique's best? It'll be something like convolutional neural networks, facial recognition, things like that. And they've gone, well, how will people interact with this? Well, it should be part of the app. It should be part of the app where you can simply apply a filter and it just works. Again, thinking about sort of the user's perspective, all they have to do to use this AI system is simply go on an app, they take a picture, and then they can apply a filter, and it's that simple. Again, as mentioned before, you can also use Users can also interact with this via what I refer to as integration, or through another system. So for example, if it's a medical field, they already have a lot of computer systems that exist for dealing with things like medical imaging, things like that. And really what you could do, rather than providing another system or application for them to use, it could be integrated into an existing one. So for example, when they take the scan, for example, they could then automatically have it detect, let's say, a probability that there is cancer or something like that, depending on what it is they are doing. And again, you have web apps as well. So this basically just refers to websites. Again, a very common way of using it. But then you can also have things like desktop applications, etc. And then what tools are available to actually implement this? So again, this is where you have a lot of options, especially around model creation and also actually the development side. So you need to think about the tools for the actual model creation and management, which we'll go into some examples. And you also need the tools for the infrastructure and the final user deployment, or the end application that you're looking to make. So then the next stage would be designing the infrastructure. What tools would be best? There's a lot available. So I've just showing here a snapshot of the big three in cloud development in this case, or infrastructure. So you've got AWS, which is Amazon. You've got Microsoft Azure, and then you have Google Cloud Platform. So what they have here is, what I love about working in this area is everybody uses acronyms, and uses interesting, product names for everything. Things can't just be called simple things. So what is being done here is sort of comparing products within each of these three that are effectively the same thing. So virtual servers, AWS calls them instances, Azure calls them VMs, and then Google calls them VM instances. Again, platform as a service, this is where you are hosting some code that then is executed. AWS calls it Elastic Beanstalk, very interesting name. Azure calls it Cloud Services, very straightforward. And then, as we've seen before, Google Cloud calls it App Engine. And again, this applies to all of it. So, you have a variety of different names and things for this, but the key thing to know is just really what is it you actually want it to do, and then you can find the tool that is suitable. And again, each of these platforms has trade-offs. Some are more expensive, but some of them have better integration with other things. It really just comes down to when you're designing your system, what might be best, and you going through that kind of research and understanding what would be appropriate. Other things to consider at this stage is, what data are you using, how are you going to store it, and how are you going to manage it? So if you're building a system that, for example, like a voice assistant, it's going to take that input data from somebody like text and images. Where's it going to store it? Is it going to keep that data for training purposes later, or is it going to delete that data for security reasons, for example? And again, there's a lot to consider here. The next stage would be creating your models. So this is obviously the bit that you guys will have probably seen the most of so far. And this is, your life cycle of, well, how do we actually make the AI part of our system? And again, like we showed before, what is your process or life cycle? For example, that Microsoft one is particularly useful. How do we actually create the models? So what development environment are we using? Most commonly, we see Jupyter notebooks being the most popular, and that's the basis of Google Colab. It's in VS Code, all these other things. But you can obviously do things like other IDE development environments as well, can be used for this. How do you train the models? How do we store them? They're just files that live on a server somewhere. And then how do you integrate them with the target user deployment? So what you can actually do here is you can take that model and turn it into an API. And how this will work is, say you have an application on a phone. The phone makes a request to this API, and the way that works is it's just a URL. It's just a web address. And the app provides the data necessary they want to make, say, a prediction on. The API understands this, and it has that trained model that you've created on that API server. And what happens is that it processes that information and then returns, say, the prediction back to the mobile app, which can then display that and use that information. There's a variety of APIs available for certain things. Like I mentioned before, Google has things like the Vision API, has the Dialogflow API. Everybody has almost their own bespoke ones because they're in competition with each other and they can all do different things. So really it's down to the research of how you want to, what you want to use, etc. So tools, okay. So just for doing the actual machine learning AI model management infrastructure side, there is a lot of tools available. And strictly speaking, as I've mentioned before, there is no right or wrong way of doing this. There is simply only trade-offs and more efficient ways of doing things. So effectively, you have various services. I've used a bunch of these before. So you've got Amazon SageMaker, which is their own bespoke machine learning studio that they have on AWS. You've got Google Colab there. You've got Databricks. I've used Databricks a lot. I quite like that, but it is somewhat expensive now anyway. But you can run it locally, so it's not too bad. And then you have things like Google AI. Again, this is something that's built into their cloud platform. And this is almost like, again, a studio that you can then do whatever you like. MLflow is also another good one. Weights and biases, again, another good one. Data Robot is a company that produces things like various applications. Dataku as well is pretty good. I mean, they are all good and bad in their own ways. And really, to be honest with you, there are so many new applications and tools coming out all the time that really they're always going to be improving and evolving. So what I would say is you know, from past experience, it can be worrying sometimes when you see these amount of tools and think, well, do I have to learn all of these? And the case is no. It's more about, you know, understanding, well, what do I want from the tool? And then you can choose the most appropriate tool. And then, you know, you can learn how that works, use it, that's it. And again, that applies to things like Python libraries as well. So as Ian has probably shown you guys already, you know, you can have various libraries that do certain things in Python, and you import them and use them as you wish. And yeah, you don't have to worry about writing the code or understanding how that works specifically, but you know what you want from that library. So that's why you use it. I hope that makes sense. Okay, so maintaining and improving your models. So how do you know how well our models work? That again comes down to your evaluation metrics and things like that, which is a big part of the training and measuring it. How do we measure the model performance when it's deployed? So once we've got it into our end users and they can actually use it, how do we keep track of it? So there's various logging software on here that can do that for you as well. So yeah, you got Streamlit and things like that down the bottom, and model explainability will tell you how well the model works. What do we do when you get new data? So are you going to retrain the model? Are you going to redeploy it? You know, how often are you going to do that? You know, is it going to be when you get so much new data? Is it going to be continuously? Or is it going to be like a batch process where, let's say, every month you retrain the model, and if it's better than the previous one, you put that out there, or you just redeploy it anyway, and so on and so on. So really, that is the whole process of considering how to design a AI system. And really, the main thing I'd say is obviously you keep asking questions about what it is you're trying to build and exactly what the purposes of the system that you're trying to create. And this also applies to, you know, software development in general, and also just product design. But yeah, this is sort of a very brief introduction into that. So a little side thing I just want to mention at the end of this talk is, how do we actually keep up with AI? So this is just a chart from a recent, well, I say recent publication. It's from 2019, so that's the last time the WIPO did this technology trends look at artificial intelligence specifically. So every year they do a different one. And this is showing how scientific publications and patent families have evolved over time related to AI. And obviously, scientific publications are first because they're obviously the ones creating that bleeding edge technology or innovation, as it were. And then the pattern families, pick up pace afterwards because companies are interested in then using those techniques and technologies that have been developed in actual products and services. So this obviously only goes up to 2017. If we were to go to, this year, for example, I would imagine the chart would be near the top of the screen by now. So, it's a rapidly evolving field with, a lot of potential, and there's a lot of people working to develop and innovate on previous work, and it's expanding at a crazy rate. I mean, just taking a look at, for example, when something like Siri first came out, I mean, it must have been about 10 or 12 years ago now. The difference from when that initial Siri version came out to how voice assistants are now is huge. Like the actual ability and things you can do with them is vast, and just silly things like how realistic the voice is, for example, because they're constantly retraining these models to produce a realistic voice and realistic response. Some of them haven't evolved too much, but some have evolved more than others. And again, that's something you'll see a lot of publications coming out all the time for this. One thing as well, I saw some guys mention things like Kaggle before. Yeah, Kaggle is a very good website, and I'll show that in a minute. And effectively lets you look at things like data sets and notebooks that people have created and enter competitions and do that kind of thing. So if you're interested in just playing around with using machine learning or AI, you can simply go on there, download a data set, have a play around it, explore it, model it, see how good you can produce a model on it, maybe even publish a notebook if you want to, and do that kind of thing. Again, using Google Colab is also an option because it's a very good development environment for doing, getting started in this field. And also you have things like looking at publications from places like OpenAI and Google DeepMind. They produce some crazy stuff, like the recent DALL-E 2, which produces images based on a text prompt, and how good that is quite frightening. So the fact that you can then say, take an image and say, oh, I want to insert this into the image, it can actually almost Photoshop it into an image very, very well. And it does it correctly. And this is all, AI generated. It isn't done by a person, hiding in the background somewhere. So it is very, very quickly evolving times we're in this field. So just to provide a quick summary of everything before I do sort of a quick AMA and answer any questions that are still there. Obviously, how do we use AI now? We have various problem domains: computer vision, NLP, predictive analytics, robotics, etc. We have many application domains, so that's basically anything that you can think of. How do these systems work? There's three main components. You've got the user-facing deployment. You have the infrastructure that actually manages the models and serves the data and serves the responses from the models. And then you have a model lifecycle and training process where you train your models, evaluate them, and then deploy them and monitor them. And then how do you go about making an AI system? These are sort of the key questions that you should be asking: is what are the user's needs? What's the problem domain? What are the solutions for this? What infrastructure is needed? And how do we manage and maintain our models? So those are kind of the key things and a short summary of what I've gone through in this talk. So thank you very much. And I believe, as per, I'm not sure if Ian mentioned, but almost have a bit of an AMA at the end. And also, I think we'll have a small break before we go to the next talk, because obviously, it's very warm today. So it might be wise getting a drink as well.
Luke, I have some questions about the that subject, like impact of AI or applied AI.
Mm-hmm.
So when we came through the subject of applied AI,
Yep.
uh, is this like we are starting from the scratch, like this completely scratch, because we are not aware about how we applied AI on the application based, like on the regular systems. So we are going to start this completely scratch, like which application we are going to use, which application we need to download it in our system to work on the AI. So we are going through all the stuffs from the basics.
So as part of that module, so for example, that assessment where they design their own AI system, we're not looking for you guys to actually go through the whole development and building the system. It's more about high level design. So obviously, if you already have that domain knowledge about, okay, well, this is the kind of thing I'd like to make, then that's absolutely what we're looking for, because we want you guys to use the domain knowledge you already have, and then how you integrate AI into it. So strictly speaking, we will go through things like, you know, how you build the infrastructure and how you do that kind of thing. But it's not going to be, I would say, totally from scratch. But it's yeah, so it's going to be based on, you know, we're more looking at doing high level things, so rather than actually developing that system directly, if that makes sense.
Yeah, it's quite like so complex and like complicated to design that all frameworks and all those process and application. So I just wanted to confirm, like when we are going to start that module in the university, so we are getting all the practical approach of it, like of all the practical approach of that module and all those base things which is included in that module. So we are getting more information about it by the practical base, not more than the theory base.
So the idea is that this module is obviously right at the end of the course. So you guys will have done a lot of the practical sort of, you know, writing code, things like that already by this point. So dealing with models, things like that. And really what my module is there to do is to, obviously you guys have been focusing on things like programming and the very sort of nitty gritty, low level kind of producing the models, things like that. And what the module is there to do is to actually get you guys to think about the high level stuff. So like I say, I'm not looking for you to provide like a perfect design of how you would actually make this system in reality. I'm just saying, okay, well, you know, if you were to build this, what kind of tools would you select, for example? Not looking to actually, you know, force you guys to build this, because that would be a
Okay,
little
we
bit
got it.
unfair.
Okay, got it. Thank you.
Yeah, is that
If I
okay?
can,
Brilliant.
if I can jump in and add to that, Luke, I think that
Yeah.
was a great explanation. The one thing I'd point out, Prachi, so you're doing like your introductory module for computing and your data visualization in semester one. Then you go on and you start machine learning, then this applied AI with the different topics that you're going to look at, and then deep learning. So as Luke said, you're getting really into the nitty gritty, and it's just progressively solving more and more challenge computational problems in a very applied and practical way. But then Luke's module takes that step back so that you can think about it in the whole ecosystem of AI and in, you know, the business relevance and the impact. But anything that we are asking you to do, we're going to give it a very practice-based examples. All of the assessments, things that we set you, you're going to have seen examples in a more basic way generally, but you will see a way of how to do that. So things like, Sir, as you just mentioned, stock prices there. Yes, we will do some stock price prediction and some all sorts of different aspects of identifying changes in stock prices and trends and things like that. And then your assignment will involve some form of prediction and a more challenging time series, but you'll have done some of that in the class nonetheless.
Actually, I'm a little bit afraid of that, like the modules and how I'm going to supposed to implement practically. That's what I am like concerned. I have so many concerns. Like we'll start in this September of it.
That's absolutely understandable, but we're taking everyone on the basis that this is a conversion course, so we're not expecting anyone to be proficient programmers, experts in AI or anything by the start. And you absolutely 100% will. By the time you hit that machine learning module at the end of semester one, you will be writing code, exploring a data set from scratch, and you will be doing a brilliant job of it. I know I helped mark those with Besha, and out of the 55 students and reports that we saw, there were 55 great reports. Okay, it's absolutely doable, but we're going to do it in a very scaffolded way by the time we get there.
Oh, okay. Thank you.
Okay, I'll quickly just answer some questions that are in the text. I know a couple of you guys got their hands up, and I'll come to you in a moment. So there's a bunch of questions here from Mary that while I was presenting. So yeah, so all these applications and sort of frameworks, things like that, a lot of them are open source because they're built on open source software. So there are some paid stuff that you can use, and strictly speaking, again, it comes down to your personal choice. What tool is best for the job that you're looking to do? Sometimes the reason they're paid for is because they offer certain features that may be useful for if you're working at a company. It's like additional security and things like that. Again, you can do all of this open source and also on the cloud, like you mentioned. It can all be done on cloud systems. When you use, say, something like AWS or Google Cloud, it's all using their own, web interface. So you don't actually have to do anything per se. When it comes to, for example, developing an end application, you may use something like, if you're building an Android app, you'd use Android Studio, something like that. But if it's a web app or something like that, then you'd use, VS Code, for example, to do most of that work. Again, I think pretty much everything, I can't think of anything that couldn't be done open source and free effectively. And that's one of the good things about this subject, is that because it's a lot of stuff is like in Python as well, for a Python module to exist or a Python package to be sort of published, it has to be open source. So you can then, you can ensure that this is all open source and it's all getting kind of updates and fixes from the community and that. Just quickly on last couple of questions, I think, Alex, did you have a question? You had your hand up before.
Yes, I was just wondering, Luke, thanks so much for the presentation. I was just wondering, because I'm very big on built environment and construction. Actually, I've been doing some, well, I use robotic equipment for my surveying, and then I do a lot of CSV converted into layouts and stuff. So, and I've got Microsoft HoloLens. I design module. I can see the complete building with the electrical, mechanical, every single thing with the Microsoft HoloLens. And this knowledge is mind-blowing. That's why I really want to get into AI, see in future how we can have virtually robot doing everything, basically. Well, the thing I want to ask is if you've got your colleagues that are into built environment research and, at BCU.
Say that again.
I'm just asking if you've got your colleagues that are into built environment focused projects and research.
That's a good question. Yeah, I'm not sure. Yeah, Ian, do you have anything there?
So I think we'd already talked, Alex, about the built environment links. So I think that's something I've made an inquiry yesterday after your conversation. But I think when you arrive in September, potentially I think it's a good conversation for us to have in terms of links and sort of next steps to facilitating that. It seems like it won't be a problem to get some sort of project or collaboration going.
Yeah, there is certainly, just to add to that actually, because there's so much crossover where, like I mentioned before, that the actual applications you can use these kinds of things and AI in is so huge. If you can think of using AI in a built environment project, then that's absolutely something that people would be interested in inside the university. So, I mean, a lot of the things for, say, the final module, the impact of AI module, in that assessment they had to come up with a AI system in a domain that they are interested in. This often then led to their final projects at the master's level being related to that. So they sort of took that further and then built a bigger project out of it. Yep. Okay, you got a question?
Okay, thank you. I don't know if this question will be for Ian or you to answer. I just wanted to ask, are there like research groups that work on virtual reality or augmented reality projects in your school?
I believe so. I believe there is, yeah. I'm not sure if Ian knows any more about that, but yeah, certainly there's, as far as I'm aware, there is, yeah. Because I've seen a lot of AI VR projects before coming up from people.
Okay, and how easy would it be, for us to volunteer to join those groups so our learning is accelerated?
I'm not 100% sure. I'm not sure if Ian can sort of expand on this. It's for the final projects for masters. They are individual, aren't they? But you can have supervisors that obviously are specialists in VR and things like that. That they will, be able to help you in. Is that right, Ian? Or has Ian vanished? Is he still here? Take it that Ian has vanished, but yeah. So from my understanding, and obviously if you want to ask Ian as well, effectively when you do your master's project, you'll have you know, it'd be an individual project, but you'll have supervisors who are obviously have your kind of project as a key interest. So if you're looking at doing VR, there will be plenty of supervisors who'd be interested in helping you and give you access to certain things, and get you access to like headsets and stuff like that. That is definitely something that, you know, happens. So when you go through writing your proposal for your master's project, you know, supervisors may approach you saying, oh, well, this is a keen research field for me. So, you know, I'd like to work with you on your project, basically, if that makes sense.
Yes, total sense. Thank you
Okay,
very much.
that's all right. Cool. Okay. I'm not sure where Ian has vanished to. Right. Okay. So what I'll do is I'll just give it a couple of minutes, and then we can go to. So I'll stop the recording for this one now. Stop recording.